Hey everyone, welcome back to my channel where I talk about all things tech and finance. And in this video, I'm going to be going over data visualizations in RStudio. I'm going to be going over the basic necessities that you are going to need in order to effectively communicate what your data is saying, creating a story behind it, and making sure that your clients, your customers, and your colleagues are on board with many of your ideas that you might have into play. Visualizing data is often a very underutilized skill for a data scientist. This is primarily because, one, we are often trying to read research papers in order to reconfigure a model that has already been proven in academia, and more often than not, many of these research folks do not publish their code, so it's a lot of pain in order to recreate their model so that we can get similar results. Two, we are trying to hyperparameterize our given model with all the various parameters in order to get the best performing model, trying to maximize that area under the curve, for instance. Or three, we are trying to create data pipelines in order to make sure all of our data streams are correct, succinct, and everything is good to go. And four, trying to understand where this model is going to go to, how to deploy it, and how best to prototype this, make sure the model is not overfitted on a very small subsample of folks, and hopefully it does not flop when we actually deploy it. So there's a lot of things that are going through our minds, and visualizations is not at the top at that heap. However, visualizations are incredibly important, especially when we are trying to communicate this data to someone who might not be familiar with our given situation. So let's get down to it. Okay, so this is going to be my demonstration on really productionalized plots. And in this case, this might look a little bit foreign to you. However, this is pretty much just like Jupyter Notebooks if you're a huge fan of Python, where this is like the Markdown area. And then within each of these R chunks we have over here, they are the code. And it's really cool to actually circle around wherever your chunks are located. You can easily just go to whatever chunk that you can go to, and really easy to debug where your stuff is actually erroring out. The way to do this is that you just go to File, New File, and go to R Markdown, and then you can create your document. And in this case, I am outputting to an HTML document. However, you can do a PDF, Word document, so on and so forth. You can change your title, but there's also other options that you can do as well. Anyways, let's go on to here. These are all the packages that I'll be using in order to help visualize our plots. Make sure you install this package, because for some reason when I was working with shapes, it didn't have the transformer package, and this is very much needed in order to help visualize some of the shapes that I'll be animating. These are the datasets that I'll be working with. There's a few more down the road. However, these are going to be the ones that I'm going to be working with immediately. So air quality, pretty simple. We got ozone, the ozone values, the solar radiation, the wind speed, temperature, month, and the day related to that. So I'm going to be sprucing this data set up a little bit more, of where I'm essentially creating 3 buckets, high intensity to low intensity, and I'm going to be creating a column value right here with the mutate function and dplyr. I'm using a case when function, of where it's basically like an if then statement, but there's 3 conditions over here. And as we can see here, when it was already run, 313, 299, 256, they are all greater than these values, and therefore we have high intensity. This goes the same for non-applicable values. I just left it as default for high intensity for all intensive purposes. So once we actually create our intensity, I made sure to run the sapply function on the intensity observations, and then I just matched up the values between the buckets and our given observations, and went ahead and I mutated the values so that we can get a factorized instance of our given observations that we have in our intensity. It's going to be my very first plot. So this is a really nice plot in order to showcase this in front of a client, maybe your colleagues. Ggplot does a very good job visualizing data, and this is pretty much all you really need for a graph. So yeah, you can easily customize your points. We have points over here, triangles, and I believe these are squares. So you can easily, play around with what your shapes look like. However, what happens if we want to pinpoint a specific area that we want to highlight within this graph? Maybe from the temperature of 60 to 80 roughly, and then maybe label it off at 50, just highlight that area. How would you go about doing that? Well, I'm very glad that you asked because I did it right here. This is really cool. So the only thing that you change here is that you add an annotation. And they have some really neat defaults, but in this case, I just used the rectangle. And you would want to specify the X minimum and maximum. Same thing for the Ys. The alpha value represents the opacity, or the transparency, I should say. So closer it is to 0, the more see-through it is, and the closer to 1 it is, you can't see anything at all. The color is just the outline of the rectangle, and the fill is the color within the rectangle over here. And of course, you can change this segment. Well, you can change this to a segment. Over here, same exact thing. You run this over here, and that is your segment. Anyways, I like the rectangle a little bit better, so I'm just going to leave it as that. You can also add more rectangles by just, appending like, another minimum over here, right there, and then maybe like a 10 and maybe like a 100 or something like that. If you run that, there is another rectangle. So you can go to the world with all those rectangles, but I'm going to delete them and stick with my one rectangle. But that is how you annotate that particular graph. So the next thing that we want to do, so using the same exact data set, I went ahead and I recreated, I just grouped up everything. So I have a group by, I grouped by the groups that were factors, and I went ahead and took the average of all the values that I'm given. And so this is going to be my high quality bar chart. Really neat. This is pretty much all, like everything that you need in order to convey a message. So over here, I took out the X labels. I just left it as blank. And then the Y labels is going to be the average temperature, of course. And then over here, right in the middle, I can't highlight that, but right in the middle of each of these bar charts represents the average for each of these groups. And I went ahead and I think I rounded it off. Where is it? I think I rounded off. Yeah, right here, temperatures. And this is how you include text on your specific columns in this case. And then I just made it an outline of black over here, and I made sure to size it appropriately for the text. And then this is where your positions are going to be playing around. Your v just is equal to 1. You can do this to like 0.5 as well, but as a result, it'll be all the way down there. So you can play around with that however much you would like. You can even put these values all the way at the top. It just comes to preference. And then notice that the colors are different. I used a palette scheme over here, a Phil Brewer. I like the pastel one. I really like it. Really nice color scheme, very bright. Nonetheless, let's go ahead and create a pie chart. So over here, I went ahead and used the other data set. Well, a new data set actually, IMS elections, and pretty much blah, 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 blah. Over here, I am essentially grouping everything together in terms of people to sum up all their counts. And then I'm just taking the proportion of the values of, this is 9% of all the counts, and this is 9.3% of all the counts, so on and so forth. So this adds up to 100 or 100%. And this is the Y position, and this is pretty much the way in order to configure all of your annotations on the pie chart effectively and efficiently. So over here, this is where the magic happens. So this is going to be my entire pie chart where I have the people who have counted, how many votes they have counted, a part of a larger whole. So typically you would use a pie chart in order to represent distributions of a population. But in this case, I just did a distribution of counts. So it's very similar. Other than that, you wouldn't really use a pie chart for anything because it's kind of tough to read, and there's a lot of going back and forth to the persons and the actual pie chart. So that's that. One of the things I want to highlight is that when you have a title over here, you can easily center that title using, where is it? Right here, element h just, so horizontal just is equal to 0.5, and I removed all of the backgrounds and ticks and whatnot. So that is going to look something like this. If I were to continue with the default settings, this is what that looks like. So of course we don't really want that, and I went ahead and I just deleted those values. So let me recorrect. Over here, there's a lot of playing around and a lot of customization when it comes to working with these particular plots, but that is how you would go about doing a pie chart. Oh, one thing, the stat is equal to identity. These are the raw values that are given inside of your particular data frame in this case. And so you see 9.04, that matches up somewhere. I think I rounded up, so 9.05 over here. So it's literally using those values. Make sure you do coordinate polar in order to make sure that your labels are correctly added or appended to your overall graph, since it is on an X and Y coordinate polar plane. So that's why those Y positions work so well. Anyways, let's move on to our very next graph. And this is going to be really cool. So I'm going to be going ahead and animating images. So the data that I'll be using is going to be Gapminder over here. And Gapminder. So the real cool thing about Gapminder is that each of the years, let's actually just do Afghanistan over here. Let's do that. So each of the years are very close to being sequential, right? And in order to visualize this, like in terms of, having all of these images stack up on each other to get a real nice imagery, you're going to need some progression of an order by the year. And you can easily visualize this when we are working with Ggplot. So typically over here, this is all of your Ggplot stuff, and then you would include the very last part, which is including the frames, and then this is going to be, that. So this is really cool, where we have all those, little dots that are going in and out. So over here, for the GDP per cap, that's your X, life expectancy, that's your Y, size is equal to the population, which the pop is over here. So that's just the size of the population, which actually represents those particular circles that are going in and out. They can grow larger or smaller. Color, I just colored it by country. So each of these dots has a very specific color associated with it, and that's a very different country. What else? GM point 0.7, so that's transparency, of course, and I just removed the legend because we have so many countries. And these are the size ranges, and then you can scale it down for the X coordinates. Really neat stuff. So probably the most important part of your animation is here. So you're going to be plugging in your Ggplot object. And then your duration, it's going to be 5 seconds. This is frames per second. And this is the width and height of your actual plot that you're working with. And I stuck with the actual, like the default renderer. And then the last thing I did, I just saved this to a GIF. And in our Markdown at the very end of this video, you can be seeing this GIF on a document. This is really cool stuff, especially when you send it to someone else. But nonetheless, let's go ahead and move to our next plot, and this is where I'm going to be working with voting data. So over here, this is the voting data that I'll be working with. I just read from a voting data CSV file where voting looks something like this, where I'm given all the states, the year, it starts from 76 and ends at 2020. And then what the outcome was for that particular state on what they voted for. So pretty much Democrat or Republican in this case. So I went ahead and I took a snippet of 76 over here in order to calculate, just get like a snapshot of what the data looks like. And then over here, these are the Centroid Coordinates for each of the states that I'll be plotting on a map. And then making sure that everything can join properly. So I just converted all of the states to a lowercase over here in order for these states to actually match up with my Centroid Coordinates, which is, I believe it's this, Centroid Coordinates. So match up with that in order for my joins to properly join. So this is the actual data that I will be plotting, v_plot, where I have all of my my X and Y coordinates, or longitude, latitude, and I have my particular abbreviation in order to label those states, the state itself, and then most important part, whether or not they voted for a Democrat or Republican over here. So really neat stuff, and these are just the outputs. So over here, these are actually going to be the snapshot of that particular plot. So this is going to be the graph. Really neat, where we have, I specifically went ahead and did Republican for the reds and the Democrats for the blues, and you do that right here. So I just did party colors, state labels. This is where the little annotations are going to appear on that particular geometric shape. use the data set over here for the Vplot, get the mappings all filled in, and then fill based on the party simplified, where party simplified is a Democrat or Republican reading from the Vplot data set. Vplot over here because they are joined. Yes. And then this is where the annotation happens. It took me a while to figure this one out, but nonetheless, we have the centroid coordinates where ideally the actual coordinates for each of these values are specifically in the middle of each one of those shapes. That was really difficult to find, but Google came in clutch as always. And then we have the annotations where, color it white. The labels are the state PO, which is just the abbreviation state PO right here. Those are the abbreviations. So that's the labels, and then you can adjust the size accordingly. I left it with white to color it with the white, and it goes really well with the background over here. I removed the X symbols and the Y symbols, the labels, I should say. And I removed the text as well, and then just relabeled the actual legend itself. So what happens if we want to try to animate this as well? So additional cleaning is needed, and a really neat thing that I was attempting to do was that I was trying to get it by each sequential year, since each of the states themselves are like a snapshot of the actual election, and everything is by 4 years. So we have like 1976, and then in this case would be 1980, where 1976, let's run that, and let's run that. Yeah, this is 1980. This is very surprising. This is Reagan, by the way. I think it was Reagan versus Carter. Very surprising though, but each of these has a snapshot, and each of these are 4 years apart. So I went ahead and I essentially just got all of my data instead of the snapshot of 76, get all my data, and then I created 3 additional data frames where I got that particular year, add 1, same data set, but you add 2, same data set, add 3, and then concatenate everything to get one large data set. And then rerun everything in order to get the sequential years working, so that the actual data, the Vplot, if we were to, just do a unique on that, and then let's go on year, unique of those years, and maybe we want to order that. I think it will run so we can get 1976. Okay, that didn't work because each of these are factors, but 1976, and then we have 1997, and then I think 1998 right here. So it can go in sequential order so that we can get like a somewhat of a more fluid animation in order to get everything under control. I've also assumed that within the 4 years after they voted, I assume that each of the states are consistently that particular party, whether or not they're Republican or Democrat, and they would only change after the vote and recalculate that particular color. So with that in mind, I used the entire data set, and now I'm going to be animating the entire thing. So this will take a little bit of time because the overall observations that I'm working with, I think it's, right here, 745,000 observations in order for this to actually create a very nice plot over here. So 5 seconds, 30 frames per second, same height and width, and render that as the same. Same colors, Democrat, Republican, and then over here, just getting the centroids and coordinates, but the only thing that's a little bit different is right here. So this is where you are attaching the GG arrange, or I should say animation, and then that is essentially calculating the title, which will be here. It will be going through all those particular frames of that year, and then transition time, of course, from the minimum to the maximum years that we are given, and then center out the plot. So I will see you when the animation is done. And then as we can see here, it didn't take that long, maybe took about 2 minutes tops, but this is the visualization of Republicans and Democrats on who they voted. I honestly thought this was like really like something was off, but I was looking through all the voting patterns and who they voted for, and I found it really surprising. Like there's like Republicans, Democrats, and they shifted somewhat. They're like like 40 years ago, like the entire country was like one, and then it started like splintering. I don't know. I found that very, very interesting. At one point, almost everyone was like a Republican, and then it started, becoming more so Democratic. But found that really, really interesting. So once that we ensure that everything is running and according to plan, we want to go ahead and go to File, go to Knit Document. And then this is where it's going to be rerunning everything all into one large script. But the only difference here is that it's going to be outputting all the outputs to, in this case, an HTML document. Okay, and this is the entire R document where we have all of our really neat and orderly Markdown comments. We have the R code. We also have the associated output for each of these R codes. And then we have, of course, just the nice blocks of each and one of these particular R blocks. And, each of these outputs, really neat stuff. We have the graph itself. We have the graph over here, and so on and so forth. So this is like a really neat way of like Jupyterizing your R Markdown or your R stuff. Really, really neat. And of course, we can get our moving images or our GIFs over here. We can also center this out. If you like what you saw, make sure you hit that like button. And while you're at it, why don't you hit that subscribe button with those notifications on? That really helps out with this video and also this channel in general. If you have any questions, make sure you leave a comment down below. And I hope to see you in my next video. Thank you so much for watching.